Okay, let's do the second part for the VRF lab. In this case, let's remember how the lab is set up. We have a global routing table that we are going to use for management traffic in the corporate, data center, and branch offices. We're going to use some .1q links in order to communicate the global routing table at several parts of the network. Notice that we are not using .1q here and we are not using .1q here because we are using VXLAN and in this part of the network, and we are going to use Lisp in this part of the network, so we don't really need .1q for data path virtualization when you are using other protocols. We also have another the user's VRF, and that VRF is configured for instance here, and we need also data path virtualization using .1q on these links. Notice that we are not using .1q for data path virtualization here or here because we are using VXLAN and Lisp. We also have the guest VRF, and we are configuring that VRF here, and we are also using .1q for data path virtualizations for the VRF guest in these links. We are going to set up a new VRF that will be the internet VRF in this device, this device, this device, and this device. So the second part of the lab will be setting up route distinguishers and route targets for the internet VRF, guest VRF, and users VRF here, and here, because later on we are going to set up BGP and we are going to use route leaking in order to leak routes from the internet VRF into the users VRF and guest VRFs in order to allow them to get access to the internet. In the last part of this second lab, we're going to extend the guest VRF to this device, and we're going to set up data path virtualization using .1q in these two links. So let's jump into the lab, and notice that we don't have a route distinguisher or a route target in DSVRF. So let's configure that. We're going to configure route distinguisher and route target for users, guests, and internet. So notice that we're going to use this route target for internet, for IPv6 and IPv4, this route target for guest for IPv6 and IPv4, and this route target for users for IPv6 and IPv4. Notice that we are going to use unique route distinguishers per VRF per router. So we should show IPVRF. This will be the route distinguishers. Let's go for router 2 and do the same. Okay, notice this is the same route target that we used here for the internet, the same route target for guests, and this route target that ends with 100 for users. But notice that the route distinguisher changes. Now let's configure router V1. And router V2. So notice how the route distinguisher is actually different per VRF per router. That is the best practice. And we are going to use the same route target per VRF. 1000 for internet, one. In this case there is an error here, because this should be 200. This should be 200. Let me fix that. Okay, so users will use the route target 100. Notice that we are only using export. We are not using import yet. We are not using route leaking yet. Later on, we are going to use route leaking between VRFs, and then we are going to play with the route target import configuration. So far so good. Now let's configure the guest VRF here at RC1, and we are going to configure data path virtualization for the guest VRF here at router A1 at gigabit 50, router A2 at gigabit 50, and at router C1 at gigabit 5 and 6. So let's do that. That will be the final part of the lab. So let's do data path virtualization. Notice that we are using native VLAN for global routing table, VLAN 1000 for the users data path virtualization. So we are going to use VLAN 2000 for let's use 2000 for the guest. This will be the IP address. So now this interface appears. So that will be all for router A1. Let's do that for router A2. Notice that if we should show IP VRF guest, we only have 3 data paths. So let's configure a new one. So this would be the new path for the VRF to connect router A2 to router C1. If we issue this command again, now we see this data path was not shown here. Now it is set up. So let's go to router C1 and do that. Let's set up, for instance, to create the VRF definition guest, and then let's set up address family IPv4 and address family IPv6. Remember that you create the VRF with definition. There is another way to do it with IP VRF, but this is the old way. This is the new way, IP VRF definition. So now let's create the data path. If we should show IP VRF, we see that the guest VRF does not have any data paths. So let's create those. Okay, at gigabit 5 with the VLAN 2000, remember that we need .1q for data path virtualization for VRFs. We are going to create this interface, subinterface, and we are going to attach that interface to the VRF with the command VRF forwarding. And then if we issue show IP VRF, we can see that now this VRF has these 2 paths. So that will be it. What we just did in this last part of the lab was creating this VRF here, and then enable this virtualization path here and here using the VLAN 2000. That's it.